angles on parallel lines. We're going to talk about those 5 things you can see up there. We're going to identify what alternate, corresponding, co-interior, opposite and supplementary angles are, and then just look at one brief example of how to use them, and then you're going to jump into some practice for today. So let's have a look at this simple diagram here. We can see that we've got this little symbol here, which tells us these 2 lines are parallel. Hopefully you'll remember from previous years, parallel lines are like train tracks. They never get closer or further away. They stay exactly the same distance apart. In this picture, they're moving to the right at the same angle from that straight line coming down. So because these 2 lines are parallel, what that tells us is that if you were traveling along this line this way, then if you turn to the right for either of these 2 here, you're turning to the right by the same amount. So that turn there. So what does that tell us about the angles? Well, it's pretty straightforward. The first thing that tells us is that this angle here, where we're turning from that off to the right, is the same as this angle here. So straight away we've identified 2 angles, this one here and this one here, which must be the same because they're both turning off at the same amount to keep those lines pointing in the same direction to make them parallel. So this one here we could also say is the same size as D. This is our first set of parallel line angles. These 2 here are the same, D and D are the same, so we can say D, let's call it D1 and D2, D1, D2, we can call them corresponding because they're the same size. How do we know they're the same size? Because the lines are parallel, so that's what tells us they're the same size. So that's straight away, we've jumped into a little fact there. We've got 2 angles the same size here. Let's look at B and D for a second. Let's look at B and D next. These 2 here. What can we say about B and D? Well, B and D are on a straight line. We've seen that before. They kind of go together to make this half angle. So this tells you that B and D must equal 180 degrees because if we think back to our previous lesson, we talked about angles on a straight line adding up to 180 degrees. We have a name for this. Okay, if B and D add up to 180 degrees, we call them supplementary. So any 2 angles that add up to 180 degrees, we can say are supplementary. We could also say that these 2 here, 70 degrees, and the D must be 180 degrees because they're also on a straight line. So 2 things we can say there. That's exciting. Got 2 things already, supplementary and complementary. Let's look and see if we can find some other things. Well, we said this one here, again, was the same as D. But we can also see that A and D here must also be supplementary. But if they're supplementary A and D, well, that means that these 2 here must also be 180 degrees. I'll highlight them for you so you can see exactly which ones I'm talking about. This one here and this one here. So we now know that these 2 inside of the parallel lines, imagine that's a train track, and you can see that A and D sit inside of the train track. There's A and D there, inside the parallel lines. Think of them as between the train tracks. We have a special name for this. So we can say that A and D are what we call co-interior. Co meaning together, interior meaning inside. Together, inside. And they add to 180 degrees. And that's the same for any parallel lines. Okay, let's keep it nice and clear. So we've got supplementary angles, we've got co-interior, we've got some corresponding. We can also talk about other angles being corresponding, i.e. the same size. When we look at A and C, we can also see that A and C, if we're going down this way, are turning off to those parallel lines the same way. So A and C. Now, we know that B and D here add up to 180. We also know, so if you think about that one there, we know B and D add up to 180. We also know that D and A add up to 180. So what that tells us is that B and A must be the same. And the special name we give to those, we call them alternate. If you kind of trace their path, they kind of go, there's B and there's A. And if you look, they kind of make a little Z. So we call them Z angles sometimes. When we look at A and C, which we said were the same, so I'll highlight them for you, A and C, we can hopefully see that when we make those, it's like an upside down F. Sometimes it will be a right way out F. So we sometimes call these F angles. Let's again think about what we know. We know A and D are the same. We know A and B are the same. We know that A and C are the same. So therefore, if we know that A and C are equal, and we know that A and B are equal, we can also see that B and C are equal. They kind of look like this. They look like an X. And we call these opposite angles. And we also know that these are equal. And corresponding angles are equal. So we've got, what does that mean? Well, it means we've got lots of pairs. Think about playing a snap or something. We've got lots of ways we can play snap. We could say B and C are the same. We could say, oh, no, don't want that. We could say, that A and C are the same. We can say that this angle here and D are the same. We could say that D and this angle here are the same. We could also, if we know that these two are the same, we could also say that these two here must be the same. They're alternate. They make that Z shape. They kind of go in a zigzag. And finally, we can also say that things like these two, while they're not the same, they go together in a pair and they add up to 180. And we can say that angles like these go together to make 180. So let's just summarize that in a slightly easier way to see. Let's break them up into separate bits. We've got angles like this, which we call corresponding. They're the same angle in a different place. I always like to think about where they're pointing, and so they're both pointing kind of this way, and they're both the same size. So they are equal. That's terrible writing of the word equal. I'm going to do it again. So they're corresponding angles, and they are equal. So these two are the same. In the next picture, we've got some opposite angles, which are also equal. Draw lines, we know which one's doing that. So three sections. We've also got C and D. C and D are alternate. They make a kind of a zigzag. Remember, this is only for parallel lines. Finally, we've got some pairs here. We've got two angles here, A and C. These are supplementary. So they add to 180 degrees. But the other type of pair that adds to 180 degrees is co-interior. So these two here, because they're together inside, A and C are one inside, one outside. C and D are together. We call these co-interior. Co together, interior inside. So those are the key facts you need to know for parallel lines. There's 5 things to learn. If you learn those 5, you can solve any question in the world on parallel line angles. Let's do one question together and see how we can look at those pairs and apply them to a question. So let's imagine we wanted to find all of the angles A, B, C, D, and E. And we're going to combine all the different facts to do it. Well, the first thing we could do is we could say, well, let's look at what pairs we have, even if we don't know all the sizes. For example, we know that A and B are going to be a pair. They're an opposite pair. We know that D and E are going to be a pair that add up to 180. But which angle do we start with first? Well, I'd look at this one and I'd say, okay, I'm going to start with angle B. Angle B is an angle in a triangle, and we know that all angles in a triangle add up to 180 degrees. That's what we did last lesson. If I subtract this 42 here and the 90 degrees here, I get 48 degrees left, which tells me B must be 48 degrees, because this is angles in a triangle. Let's make a note of it for later. Now I know that B is 48 degrees, I can find out the size of angle A. We know that A is opposite B, so it is the same size. So this one must also be 48 degrees. Let's do C next. We'll do it in a different colour. We know that C and A are supplementary. They're both on the same straight line and they're touching. So they add to 180 degrees. Angles on a straight line, just like we were doing last lesson. So if we do 180 degrees minus A, which we now know is 48 degrees, we're going to get C, which is 132 degrees. Okay, next we can look at some of the angles that we have. Now D, E, and F are going to be slightly harder. So we know that these two lines here are parallel. So let's look at angle C, this big one here. Well, we know this one here is made up of those two lines there. We can also see we've got another angle that looks kind of the same down here. They're both on this same parallel line, and they're both coming the same straight line off of it. So that tells me that this angle here must be the same size as C. These ones here are corresponding. If I know that this angle here is C and corresponding, then I also know that B and F must be corresponding, which means they're the same size. So F, therefore, must be the same as B, which is 48 degrees. Finally, we've got D and E, but obviously we've got that line crossing halfway. Well, we know that this angle here is going to be a right angle. And we also know that this angle here, therefore, this is where we have to zoom in a little bit, this angle here, I'm going to shade it in red so you can see it, is also the same as this one here. So that one there must be A. If this is A and this is 90 degrees, well, this one here, getting a bit small now, well, this one must be 180 minus A minus, well, 180 minus the 90 degrees in the corner. We know that A is 48 degrees. Minus those, 138 leaves us with 42 degrees. So this one here is 42. If this one here is 42, we know that this one must be supplementary. I'm just looking down at my screen, I should hold up a bit higher. So we could do 180 minus 42, so that's 138. And finally, we know that these two are opposite. So this one here is 42 degrees. And now we've found all of the angles, lots of writing, a bit messy. Maybe we should try a new page with a slightly more tidy version of that. So let's just go through that a bit quicker. We said this one here was angles in a triangle, so that made 48 degrees. This one was the same. We also knew that this one here was the same. We then said 180 minus the 48 gave us 132, which meant this one here was 132. We then said, well, this one here must be the same as this one here, so we said 48 degrees. We then did angles in a triangle to get this one here, which made this one 42 degrees. We can also see it's alternate to this one. This one here must be alternate to this one here. Shade it in green so we can see it. We then know that this one here must be 132 degrees as well. And finally, this one here must be 48 degrees. Sorry, no, that was wrong entirely, sorry. This one here is 42 degrees because it's opposite. Good job I checked my answers, and this one must be 138 degrees. So that's how we can use parallel lines. I'm just going to go back, I'll leave it on this key screen here. 5 things to learn. The more you practice these, the more familiar they become. What I'd recommend is that you either write these down into your books or you take a little screenshot so that you've got these to refer back to, and you can use these to try the parallel line questions today.